All right, my name is Jay, and this is going to be a short intro video to systems of differential equations. All right, let's get started. Doing this, I'm going to assume that you have a little bit of prerequisite knowledge in solving systems, matrices and vectors, calculating eigenvalues and eigenvectors. This one's very important, and, well, if we're going to solve multiple differential equations at the same time, we got to know how to solve at least one, right? So, with this prerequisite knowledge, let's look at what a system of differential equations normally looks like. It looks like this, right? We have two functions, x1 and x2, and their derivatives in two equations. Usually, we like to represent that like this, where this matrix here is just your coefficients, right here. And then this guy is your derivatives, and this guy is your functions, okay? And to express that more generally, we can say that this coefficient matrix is just any matrix, okay? Now, let's look at what our solution is going to look like, okay? It's going to look like this. This eta are just your eigenvectors right here, and then lambda are just your eigenvalues, okay? Now, when you're solving these systems, you're generally going to run into three situations, okay? You're going to run into real eigenvalues, complex eigenvalues, and repeated eigenvalues. For the sake of time, we are only going to look at real eigenvalues. However, I have a link at the end that can teach you how to do complex, repeated eigenvalues, and even forcing functions, okay? But let's look at real eigenvalues. Taking our general form, this is what it looks like in terms of real eigenvalues, okay? We have eta here and lambda here. And we have these two parts because we're going to have two equations, okay? Let's look at how we apply that in an example. We love examples. Here we have our system, our coefficient matrix, and then some initial conditions right here. If you can't see it, this is 0 and -4 right here. First thing we do is we calculate the eigenvalues and vectors of this coefficient matrix. So we subtract lambda off the diagonal, take the determinant, and set that equal to 0, okay? And that gives us our eigenvalues. And again, I'm assuming you've seen this before, but that link that I mentioned, I'll show you at the end, has a review on eigenvalues and eigenvectors if you need it. Now, for our first eigenvalue, we plug it back into our matrix and solve the system that comes out. And that gives us our first eigenvector. Then we do the same thing for our second eigenvalue, okay? We get our second eigenvector. Now, we have both of our eigenvectors and values. Now let's plug those into our general form of our solution, okay? If we do that, it gives us this. Notice lambda 1 right here, eta 1 right here. Same thing for this side, okay? Now we just need our constants. We need C1 and C2, right? So let's calculate that real quick. Using our initial conditions right here. Notice t equals 0, so we plug in t equals 0. Then x of 0 equals 0, -4, and so we plug it in right here. Now, what that gives us, we have these two vectors. Let's just distribute C1 and C2 into each of these vectors. And that gives us this system of equations right here. Now we just solve that for C1 and C2. We have our constants. Let's use those. We just plug these in to our solution here. And this is our solution, okay? And we also have to keep in mind that this is a system. And so we can also express it like this, which is a perfectly valid way of expressing it. Here, we just distribute this guy into this vector, and this is what we get out of it, okay? Let us review what we did. So, your first step should always be find your eigenvalues and eigenvectors. That gave us these. Then we plugged it into our formula here. That got us this. Then we just used our initial conditions to find our constants. It's pretty comparable to solving regular differential equations. You just got a couple vectors in there now, so don't let the fact that there's more equations scare you. Here's some helpful resources. This top link is that link that I've been mentioning all video. Has lessons, examples, great for teaching yourself how to use complex eigenvalues, repeated eigenvalues, and forcing functions, okay? And here's some additional resources if you want a different perspective on any of this. Thanks.